a bit of an insight of late that maybe people, maybe including myself, have not really appreciated the information structure of natural language. I guess we all think we understand text because we all read, but I don't think people are really aware that the knowledge contained in natural language has a structure, a natural structure to it, statistics. And it's not really like, it's not like anything we're familiar with, which comes as a surprise, I suspect. So the first thing I'm going to show is really how this all starts. The basic underpinnings of this method lie in the information, the structure of human language and how we organize it. So I'll just share stuff now. Yeah, that's it. So this is a paper which has been around for quite a while. It came from, I guess, the glory days of complex systems research, and it's about the small world of human language. Well, that's what it's called. What it's showing is that how words and concepts interact in human language in their sentences, and how it's not random, but it's not, it has patterns which I guess we're not familiar with until you start, I guess, doing systematic relational content analysis. You start seeing how we actually do this. And so what they say in the abstract is that, that this allows humans to construct an astronomical variety of sentences from a limited number of words, of ideas. It's my Lego model, right? So the idea is that language is like Lego. And you know, we have a bucket of Lego bricks in our brains, and we select the blocks we want to use to construct a narrative. And so this construction process is extremely fast and robust. The co-occurrence of words in sentences reflects language organization in a subtle manner and be described in terms of a graph of word interactions. And what I think is it reflects language organization in the brain. So what we see here and what we see with Leximancer maps does, in a very direct way, reflect language organization in the brain. Simply because when I'm writing or speaking, I'm thinking about something, a concept, and I select words to express it. And the concept I'm thinking of, it dictates and constrains the words I use. And of course, as soon as I use a word, that constrains the next few words I could possibly use. But we change topic after a paragraph, or a couple of paragraphs, we go and think about other things. So if we look at that word co-occurrence usage within like short, like 2-sentence, 3-sentence chunks, paragraphs maybe, it would show you organization in the brain of not only how concepts are considered together as narratives, but also how the words are attached to those concepts. Because, you know, I think if you think about it very long, you realize that we use words to indicate different things, and a word can change its nuance, its sense, what it means, depending on what I'm talking about. So it really is Lego, and a word doesn't always mean the same thing. It's not like a programming language. It's not like mathematics. It's not even like a relational database with categorical variables or you know, a quantitative survey. It's different. So these guys, these researchers go on to show what that structure is. So they look at it as a network of words that co-occur in sentences. What they find is a thing called the small world network, and it's a particular type of network. If you ever heard of that game, 6 Degrees of Kevin Bacon, I think it used to be called, or the fact that if I want to make a connection in my social network from me to a stranger, there's actually a surprisingly few number of connections I need to make to find a link. And they call that a small world and the small world effect. So just their graphic here, this is a network. And this is kind of showing what a small world network might look like. And it is no coincidence that Leximancer maps are surprisingly similar to this. So a small world, right? What is it? What are the things about a small world network? Well, it has big hubs. Think of it as the bus network or a train network, or even the network of cities in a country with their roads between them. You have the big hubs, the big communities, the central stations. They tend to emerge to connect together the whole network, and the routes that go between, like two small towns in different parts of the country, they will head towards those central cities, those metropolitan areas, to make their connections. And so it's this sort of network with a few very highly connected nodes and a lot of very weakly connected nodes. And we see this in a lot of real world networks. The internet is a small world network, the connection of computers in the internet. The connections of people in the world, the social networks that form, they are small world networks. And I think we all know a person who's very well connected. I mean, I have a friend who I'm sure knows everyone in Brisbane because, well, they seem to. And if I wanted to make a connection to someone, well, I would probably go through her. And what we think is that natural processes, this automatically kind of evolves because it's efficient, it's robust, we can quickly make long connections, and it's efficient because if you destroy a link in a small world network, there's usually another route, another pathway through the network to get where you need to go. I mean, the internet, we use this all the time. Links go down all the time, but we rarely notice because there's always another path. So that's a paper I recommend if you want to understand the nature of the information is that we're looking at, we're trying to model. Before work like this, there was a thing called Zipf's law, which is spelled Z-I-P-F. And that first really showed this, that the distribution of the frequencies of words in text, basically. And what it showed was there are a few very highly frequent words and an awful lot of very infrequent words. I think there might be an image in here which shows this. Yeah, and this is kind of, so this is connectivity distributions for words. And you'll see this in a Leximancer map shortly. There are a few very highly connected words and an awful lot of very weakly connected words. And that is a problem for an analysis process. If you're trying to model or analyze text, most words you look at don't occur very often. So, and the words that are very frequent tend to be rather meaningless, okay? A word like culture, sport, they're pretty meaningless. They have so many meanings that they become almost meaningless. So that raises a question. How do you analyze data where you either look at really frequent words that don't mean a lot, frequent concepts that don't mean that much, or you look at very infrequent words or concepts which aren't well supported. They only occur a couple of times maybe. So I guess what we do and what content analysts have done over the years is you start aggregating those lower frequency words together into ideas. So you gather together all the words that mean a certain thing to try and make the process easier on yourself. Because analyzing 200 different variables in a data set, modeling that is really very difficult to do. You'd like a small number of variables, but then if you make that too small, you lose all the nuance and the narrative and the subtleties in the text. It just becomes, if I have a survey about sporting culture, I either know it's about sporting culture, which tells me nothing, or I could look at, 300 low frequency words that are all different. And how do I make sense of that? It's 300 different things. It's It's kind of like it's the death of 1,000 cuts, I suppose. So anyway, that's very important, I think, to understand the nature of the knowledge and information we're trying to capture with this process. So I hope that was as interesting to you as this is to me. So let's just stop that sharing now. And I guess I've got slides. I'll quickly show the slides, which are about Leximancer as a tool to model this sort of data. So, but I won't spend too long on these slides. Okay. So what is Leximancer? We've had a quick look at the basic nature of the structure of natural language, and you can consider it as a small network. So how are we going to model that? So Leximancer took the approach of content analysis, and Leximancer is a tool for doing automatic content analysis. Although, I mean, not everything is automated. We are not about creating artificial intelligence which replaces the human. That was never my aim, and I find it frustrating that the so-called data scientists these days who just build robots and try to automate processes using deep learning networks, that they seem to be trying to replace the scientist and the science by, well, just in case you weren't aware of this, they use neural network modeling, which tries to take care of selecting what to measure. So, you know, they'll just dump in a whole lot of data, words or numbers or whatever, and they'll rely on this neural network to work out what are the important variables to pay attention to measure. And there is a subtext there. They don't say it explicitly, but it's definitely there. The idea that this removes the need for a scientist who knows what are the important variables to measure. And I take strong exception to that, because what they're really doing is they're giving examples. They're getting a human to come in and give examples of data, of what data means. They call it exemplars, or they code data with the dependent variables that they think are important. Like it could be sentiment. So they'll go through, take text, and they'll get some human to code a sample of text with sentiment. And then all the deep learning network, this magical AI, which is supposed to be almost sentient, all it really is a parrot that learns what words in the data correlate strongly with the tags that some human has assigned to it. So all it really does is learn how to parrot that prediction. And they sweep under the carpet all that implies about who were the people who tagged that data? What theory were they working on? What bias or expectation? And that data that they coded, it probably was for a different population, used different language usage, talked about different things from your data. So this supposedly sentient thing that they've created to replace a scientist, it isn't. It's just a way of causing uncontrolled systematic error and bias based on the supervised learning. And I think it's hideously dangerous. So Leximancer is never about that. We wanted a tool that was transparent. You can see everything about the model. It's driven entirely by the data you give it on the day. So we don't train it on North American college student data or business newspaper data and assume that it suits your data, because a statistician would never build a model on one population data and then draw a sample from a different population and apply that model, because it just wouldn't work. And yet with text, we seem to think that it should work in some areas. So anyway, I should get down off my soapbox, but I do feel strongly about this because, I've spent 15 years fighting against a torrent of rubbish data science, particularly in the text analytics area, where their assumptions that a word always means the same thing, independent of who's speaking, where and when and what culture they come from, well, I think it's going to lead to either gross misrepresentations of data or a failure in text analysis completely. When people realize that the emperor doesn't have any clothes, that it doesn't actually work the way they're doing it. Anyway, so Leximancer is data-driven and your data. So it builds concept models and concept networks from the data you give it. And it's designed for you to interpret. It's designed to, well, it's an analyst support system to give you awareness of what the patterns are in your data. Content analysis, well, I won't belabor this, and if I do, I'll run out of time anyway. So content analysis is mostly about coding. It's about getting text and coding it with the concepts that are present in each text segment. And I talked at the beginning about, when we use the Lego, we use it in finite units of text. So Leximancer uses 2 sentences. It could be 1, it can be 3. You can change that setting because that's the range of the concept. What I have in mind when I start a sentence, I change topic by the end of the paragraph. So the words within a chunk correlate together. So there's some words in here which indicate family matters and also the idea of female. There are other things mentioned in here, obviously. And so that comes back to what I was saying about the scientist, knowing what they need to code is still true. Now, Leximancer does take some responsibility for that if you let it. If you use it in its automatic setting, it will build a code book for you from the data. It does that using the word statistics in the data that you're looking at. So we would never use it to build a representative thesaurus from different data from what you're looking at, because that would be misleading. But don't believe that this is the only way to use Lex. You can take full control of what concepts it builds. It's just a slightly more advanced thing, but you can start your own concepts, and you can totally turn off the automatic concept selection Leximancer. So, it's just the automatic setting is mainly used for exploratory work, grounded theory work, getting familiar with the data set. So content analysis is mainly thought of as coding, but what you're doing there is the techniques that are important are to, well, first of all, go and get your data. Sampling, depending on what your research question is and how general your results need to be, that dictates how you sample your data and from what population you take it. You should also think about what unit of text you want. Is 2 sentences okay? Leximancer uses that. It's mostly okay. But for some data, if you're doing a collection of abstracts for articles, you would make it 1 sentence, because the abstracts are very condensed, and 1 sentence can summarize a whole paragraph in a journal article. So, and if you're doing interviews where there's a fairly lively discourse between the interviewer and the interviewee, or between people in a focus group, I would recommend extending the codable text segment to 5 or even 6 sentences, and to let it cross those paragraph breaks. That's an advanced setting, but just in case any of you are already there, I would recommend that for certainly some styles of interviews to build the best model that you can. And this is about building an informative model of the data that you have. So then the question of what constitutes each of your concepts, that is key. I mean, that's the key of being a scientist or researcher is having experience of the literature, of the content, of the community that you're getting data from, to know what are the important concepts. Now you could, I don't know all the data I look at when I'm consulting or doing demos for people. I can't possibly be very familiar with their communities and the data up front. So I would use an automatic map to very quickly gain that familiarity, but it is still important that be done. So that you can work out what concepts will answer the question you're interested in. I've talked about, well, maybe I haven't. Anyway, we'll talk about latent concepts. I did kind of mention that Leximancer built its concept model from the data. And this is, it's a thing called a latent concept. There are techniques called latent semantic analysis or topic modeling, which you'll see in the literature. They are similar in a way to what Leximancer does. It's a technique for looking at text, looking at how words co-occur within those sentence units and working out families of words which travel together like our good friends. And why are they good friends? Because the people who wrote or spoke the text had this shared vocabulary that they used to talk about an idea. And that's what it's trying to measure. I know some people, some places in the literature, they've misunderstood. They say that in Leximancer, a concept is a word. That's not true. It has a word certainly is the name of a concept, but I couldn't think what else you could do. You have to call it something. And in calling it concept J15 is even less useful than calling it concept rifle. So yeah, sure, on the map, it looks like a word, but if you look in the thesaurus, and if you read the, our behavior research methods paper, which validated the tool, you'll see that a concept is a latent, latent measurable, a collection of words with weights which travel together. It's a characteristic vocab to describe the idea. So this is the idea of a firearm in a certain document represented by a vocabulary, and we give it a name because we have to represent it in the model. It's basic semiotics, but that doesn't mean that's all there. So Lex will build this latent concept of words with weights. And well, what does it do with that? It uses it as a coding dictionary. It's called a classifier, so that any a two-sentence piece of text, if it has the words Mauser, Manlakakano, rifleman, if it has those three words in, it will add up the numbers, the scores, and if it gets over a threshold like 12, it will code it. It will basically tag that chunk of text as saying it's about the rifle concept, even though it's not using that word. So it's implicit coding, where people have mixed it up, used different words, it can code it with being about the idea of the firearm. So that's the first layer of generalization, of data reduction, where we get the vocabulary of hundreds and hundreds or thousands of words, and this maps them down. So like this is a collection of what's here, maybe 50 words mapping down to one concept. So we can get a 50 to 1 reduction in the dimensionality of this model by using the thesaurus. So we've talked about coding. Once you've got coding, the system counts how many times does code family appear in a text segment. And it does that for each concept. But it does more than that. It counts how many times they co-occur. And that's where things get really interesting. It'll count how many times does family code together in the same text segment as female. So you start getting correlations forming there. So that's your coding. So coding as a technique in content analysis, in the early years of content analysis, in the early 20th century, they just counted frequencies. how many times does a code appear in the text or in the newspaper articles or whatever it is you're coding? And they looked at frequency, they looked at how those frequencies change with time or with source or whatever segment you're looking at. Those word tags, those Wordle, it used to be called Wordle, word clouds that you see on certain websites, they are nothing more than word frequency models. In the word cloud, the size, the font of the word just indicates how frequently it appears. But they're not very expressive. All they are really is a ranking by count. They don't tell you the different senses. So if I know that sport is a frequent term, but I don't know what it co-occurs with, that really doesn't tell me what kind of sport we're talking about in those instances. So content analysts decided they would look at relational analysis. So how many times does sport co-occur with culture or sport co-occur with violence? Because that tells you more. It tells you the senses that word are deployed in. With that Lego model, where do I put that brick? What else do I put there in the sentences? What stories am I trying to tell? So this is called a second order model because it looks at correlations between two variables at a time, and it's more expressive. Then the content analysts thought, well, maybe we can do better than that. Maybe we can build a graphical or visual model of all the information in this relational analysis. So what they're about here, and they didn't really see it as a network analysis back in the early days. They called them relationships. But what it really is network modeling of language. And that takes us back to the very first thing we're looking at, is that small world network. That it is a very natural thing to do. Perhaps the best fit for modeling language is to build a network out of it. So this is one of these cognitive maps, an example of it. This isn't built by Leximancer, and it's actually built by a market research technique, probably based on focus groups or something like that. But it is a concept map or a concept network. And it's meant to be fairly intuitive. Well, the people who build them hope they're going to be intuitive, but maybe they're not. And the more you look at them, the more you realize that they're probably not as intuitive as we might think. For example, why is neat colors a bubble by itself? What caused that to happen? Why are silver and lime green separate? Why aren't they all packed into the neat colors theme? So what constitutes a separate item? What are the connections? Why are there strong connections and weak connections? And what is distance? Why is silver at one end of the map and good traction at the other end? How are those decisions made? What does that tell you about the mental model, the schema? The technical word is a schema. A model of knowledge is called a schema. And people who deal with databases, they know what a conceptual schema is. And you can extract schemas from natural language, and that's what Leximancer does. This is also a schema, which is taken from focus groups. So, so a connection, there's the fact that there's a heavy connection between Fun to Drive and Volkswagen Beetle probably means a lot of people mention them together because they think about it together. And what it then tells you is there's a narrative which says that the Volkswagen Beetle is fun to drive. That's a common narrative. We can see another narrative here. Volkswagen Beetle has neat colors, which include silver and lime green. Okay, so these connections, not only are they the fact that ideas are correlated in the language, but it shows you those narratives that are forming. Distance. So if you squint a bit and look at this, what do the concepts at the top of the map have in common? And how are they different from the concepts at the bottom of the map? So it's not the fact that one's positive and one negative sentiment. I'm not a big fan. I'm actually really not a big fan of that silly dichotomy. well, anyway, that's a more complex topic when I show how to use Leximancer for sentiment analysis. I think sentiment analysis should really be thought of as frame analysis, if you know what that means, but we can talk about that at another time. What you can see here is there's a frame at the top of this map of aesthetics, things being fun and neat. Whereas at the bottom, it's more pragmatics. Things are inexpensive, or that, you know, they're good to drive. They have good handling characteristics. So perhaps this is more pragmatic and this is more aesthetic. And these sorts of dimensions, you'll find these in research techniques such as multidimensional scaling, but also principal components analysis and factor analysis, where you're looking at those hidden dimensions within complex data, multivariate data. All right, so moving along, content analysis engine. So Leximancer is a content analysis engine. You can take a lot of control over it. It's a tool to be used. Just because, you know, you put some data in, yes, you can press the button and get a model out from Leximancer. You shouldn't just drop that concept map in as your result. You really have to do the sense making, look through the underlying data, and then tell the story properly. And B, it isn't the only model you can construct from text. It never is. You can create your own code book. You can also ask Leximancer to create custom code books around particular themes. It's called profiling, and it's in the manual. And it's a nice way where you can answer different research needs from the same data set. Say if you've got a big survey, big collection of data, and you want to look at it from different perspectives, profiling can do some amazing things for that very quickly. But you still have, you have to decide your research question, select your data sample, and do that sense making of the final model. One big difference between, well, there are many differences between Vivo and Leximancer, or Atlas TI or the other manual coding tools. There, you have to put in the effort while you're doing the coding. And it takes a long time. Leximancer takes a short time, but you have to make sense of it. So, it will take me several hours to make sense of a data set if I'm going to do it properly once the model is ready. Some people have commented that that not knowing what the data is like when the model is being built is a disadvantage. I disagree. I think getting a model which is fairly unbiased to begin with, an exploratory model, is a great way to learn an accurate understanding of what's in the data. Once you've got that accurate understanding, you can then go back and refine your model and take control of Leximancer to create your second or your third map. And you should do that. I think it's a very useful thing to do. But to say that having a grounded awareness, an unbiased grounded awareness based on your first model, to say it's a disadvantage, I don't agree. I think that's a mistaken understanding of the research process. So this is just a quick slide of what a Leximancer map looks like. This is that small world network, that schema of a conceptual schema of what's in the data that was discovered automatically. On the left, it should be treated more like a qualitative artifact rather than, you wouldn't get out your ruler and start measuring these distances. Just look for what concepts are near each other and what are far away, and look at the factors, the dimensionalities that form, and the general clustering, and the narratives that form. On the right-hand side, there is more quantitative, the ranking of those concepts and their frequencies and co-occurrence frequencies. So yeah, using it for publications, analysis of publications, systematic literature review, developing a schema or a definition for a research field. I've seen papers which use it for that. Doing survey analysis. And with Leximancer, you can include the categorical variables and the demographics, like Likert scales and gender and things like that. You can include those in the model, along with the concepts derived from the open-ended. Media analysis, so social media, newspaper, parliamentary speeches, submissions to an inquiry. So when an inquiry opens up for public submissions, that's a great source of data. You can find parliamentary inquiries that have had thousands of community submissions all across Australia, and you get a nice cross section. And then you can use profiling to discover models of all sorts of different stakeholder groups and lobby groups from that. So if you're interested in learning more about content analysis, I recommend Weber, Basic Content Analysis. It's a Sage publication, so it's not too long, and it's pretty succinct. Okay, this is our validation paper. So if you want to use Leximancer as a research tool and talk about it in a publication, I recommend using this as your citation, because we go through and do cross-validation of the method, various different ways. We also talk about technically how Leximancer works, and yeah, it's a fairly long technical read, but it is a peer-reviewed validation of Leximancer as a tool for creating. So Mike Humphries was a professor of cognitive psychology, so it really was validating it as a psychological method. Couple of papers which use Leximancer well, which I've selected, and these are, you can find them if you go to Google Scholar, or if you go to Leximancer website, you'll find these three citations. You can find lots of publications which use Leximancer on Google Scholar. So if you search for like Leximancer Education, Leximancer Business, or whatever in Google Scholar, you should find some papers there. Okay, so that's more than enough on that. And so now I guess time for some questions. I intend to move on to showing literature review that I've done using Leximancer. Well, I put in a bunch of my own journal articles, and I'll kind of just take you on a bit of a tour through things, how I did that, and some of the tricks. So this is a Leximancer interface. It's organized so that your projects are on the left. These are, perhaps a better name for these would be models. Now, your model is not stored. It's not the case where the model includes the data for it. Your data, if you're using desktop Leximancer, your data sits on your hard disk, on your own, C drive. And when you create a model in Leximancer, so here I've got a literature review of my cognitive psychology and cognitive linguistics papers. In this folder, which I've created, I just did create project to create it, and it would, well, I can do it. I can create a quick test project. Let's just call it example. So there we've got a model here, a project, which is called example. And this is its control panel, which opens up. And what you do is you point it at the data set. So when I click select documents there, I need to go and have a look at my hard disk and find the data that I want to model in this project. And by this means, you can have many models of one data set. And we would encourage it, right? If you don't know the data that well, make an exploratory model and just run it on defaults and have a look through it. But then go and make some, if you want to do some different types of analysis, create some more projects, many as you like. I mean, you don't have to pay for creating models. You can do as many of those as you like. So that's just creating a project and binding it to data. This is This is a model I created based on a folder of important papers from my research area. So, I mean, essentially what I did was I went onto my hard disk. I found my folder where I keep all my papers, wherever that is. Papers, yeah. Found the folder where I keep my heavy hitters, the landmark papers in my research area, and I just dragged that across. I dragged the whole folder across, and then Leximancer will look at all the files within the folder. You can drag individual files across, but the easy way to do a whole lot is put them into folders. And then, so I ran this through. We can have a quick look at the model. I'm going to minimize my project drawer so I get more screen room. So this is the schema, the concept map that's been extracted from this data. I can simplify it a little bit to get a quick look at the framework. Now, you might, these words here, the colored words, you might wonder what they are. Well, they are purporting to be theme names, and each of these bubbles is called a theme in Leximancer. What they actually are is clusters of concepts, and it's a hierarchical cluster too. You can change the hierarchy, so you can have a few very broad themes, very high up the hierarchy. So at some level, my research here divides into words, memory, and language, and that's not too bad actually. I mean that does kind of capture it. Or I can go low down the hierarchical model and look at much smaller, more specific themes. So I can see, more about information and memory, recognition. So it's a bit of memory work over here on it's cognitive psychology, essentially. Whereas this is the structure and theory of human language and communities, how they use language. And this is about word usage. This is much more, I guess, more engineering, less theoretically driven. This is more just about word usage. So you can look at the hierarchy through hierarchical clustering. If you're interested in hierarchical clustering, it's a method, a data method that's out there in the literature, and you can certainly read about that. You can turn off the themes entirely if you want by moving that theme size right to 0, and we can look at the underlying concept network. So these are those concepts. There's hierarchy here too. I can bring in those hub concepts. This is a small world. So we come full circle again, looking at the small world network of the way concepts are used in human language. So in this collection of papers, I can see word and words. First of all, they're close together. That's great. That means that their meaning is very similar, which is nice. And I might, if I were motivated, I go and merge them. But the model's already showing me that they have almost the same meaning anyway. Here I can see language networks, linguistic networks, structure. I can see memory as a system, data and information. So I can work down the hierarchy. That's another way to look at it. I can do that factor analysis where I look from one end of the map to another. We've already kind of seen that, but let's take this right up. The hierarchy very high. So that goes back to where we're looking at as a triad, as language, words, and memory. So I guess there are two factors here. One's a dimension which goes from memory to words, and another which goes from memory to language. So a couple of factors here, which can be very theoretically very interesting. And the times, when I've worked with academics and we've come up with new ways of looking at research data or a research discipline, we found new ways of looking at it, which are interesting to publish, is when you increase the theme size up pretty high and look at the major dimensions, the dimensionality of the thing. What are the trends across the concept model? Now, specific, so that's interesting for literature. There are some techniques I've used here. So in the text processing settings, and again, this is in the manual and it'll be captured on the video here. So I don't really have time to do revision and revisit these. But what I did, I turned on file tagging. So in the text processing settings, there are ways you can add what's called metadata. Metadata is data about data. What file was the sentence in? What folder was the sentence in the hierarchy? And you can put your data into a folder hierarchy with Leximancer. So you could group these publications. I could have grouped them into folders by year or by decade. I could have grouped them into folders by major researcher. And I could put those into hierarchy. So I can have all sorts of different information about these articles, where they came from, what time, who, that sort of thing, put it into a folder. And I can turn on folder tagging as well. So these two settings turn file names and folder hierarchies into tags, which get automatically coded to every text sentence in the data, every text segment, and will appear in your model. So that's how Leximancer approaches that's those sorts of static tagging or metadata attachment to data by using folders and file names, or by having, if you have interview data, which is transcribed with speaker labels, there's a thing called dialogue tagging, which again is covered in the manual. I don't have time to look at that right now. But anyway, I turned on file tagging, and the result of that, if we have a look at my concept editor, okay, my concept editor, here I see the automatic keywords, the seed terms to build those concepts. So these are the words that are statistically important in the data by not just frequency, but by co-occurrence usage. But in auto tags, I have every file name gets to be a variable. So here's a paper by Jeff Hinton on mixture maps. Here's a paper by Mike Humphreys, Bain and Pike. And so they become labels. And then later on, I can add those to the model. So this is where I control the model. It's called concept coding settings. It's got the balance scales. So if I were asking my research assistants to go off and code the data, I might, as a content analyst, I might create a code book, a set of concepts that I would like possibly to have coded into the data. So these are all the concepts that are machine learned. I've removed some of them, I've excluded some of them, you can see, but these ones that are gray are in the model. I've also said I want them coded by the name of the file, the name of the paper. So I've got those in there as well. And in my model, I've selected a subset of the concepts, the ones that are interesting, and put them over here in the mapping concepts list to go in the model. I've also selected all the file names to go in the model, those file tags. So that's how I can control the model. Another tip I've used is to, in concept seeds, this concept seed editor here, which has a little editor icon, we saw the tags. What I also did was I went over here to user-defined tags. Now, a lot of things going past here, don't worry if you miss them, but these tags are like fixed variables. The machine learning doesn't go and build a thesaurus of words around a tag. It just uses the words I specify. So I created a tag called bibtag, and I edited that and went through the lists of frequent names and frequent words and found these things, pp, vol, and volume. And in this data, they are very frequently used to indicate a bibliographic entry at the end of an article. So what I'm about here is I am creating this classifier, which looks for these terms it's called bib tags, so it's going to tag them as being bibliographic entries at the end. And what I'm going to do is I'm going to then use that tag to filter all or as many of these as I can out of the model so that you get much less bibliographic content in the model and more of the meat of the articles. So I've created this classifier as a user-defined tag, and then I need to use that. So I go to concept coding settings, and I go to a thing called kill concepts. Don't use kill concepts unless you're comfortable with what they do, because if you use a kill concept, you will remove data from the model. Like whole paragraphs of text will disappear based on this filter. So I've told it to filter text segments that have one of my bib tags in, vol, pp, volume. So all those citations, well, any ones that have those three terms in will get filtered out. They won't contribute anything to the model. The name of the article won't be coded. It'll be removed. If I went, if I decided to put in a frequent concept, like, I don't know, what's a good one? Grammar. If I put in grammar as a kill concept, that would find any text segment was coded with the concept of grammar and wouldn't code it with anything at all. So don't use kill concepts if you just want to take something off the map. That's not what they're for. They're for quarantining off all the text that match a particular code classifier. If you just want to take some concept off the map, take it out of the mapping concepts list, and it just won't code into any text. Think about it this way. If I have a long paragraph which says quite a few things, I might not want it coding with, who knows, maybe there's PP in it. It's talking about pages and documents. So if I don't want it coded with that, then I take it out of the mapping concepts list. But it would still contribute other things. There are other concepts in it and other concept relationships which will still appear in the model. So if I do value its contribution for anything else that it's coded with, that's when you use the mapping concepts list to take out the unwanted concept codes. If you want to suppress the whole text segment entirely, you use kill concepts. Anyway, so that's using the bib tag trick. So in this model, it's got much less bibliographic content, basically contaminating it. And so what we can see is if I go down the rank concept list on the right, I can see the frequency ranking of concepts. So language is the most important by frequency, words, memory, etc. I can scroll to the bottom and see all those file tags. And so how much text have they contributed? Well, this Wittgenstein is obviously a long piece of work, and it's contributed 3,200 text segments. This Nick Evans paper, who was a linguist at ANU, is obviously fairly long as well. So what I can do here. So now I've got this as an index. So if I want to see the text that comes from Griffith, Stavers, and Tenenbaum, which is about topic modeling, I can click 908 and I can see all the text segments from that paper. And I can click on the link above that to see it in its original context. So this is that article. So what else can we do with that? Well, instead of clicking 908, the text, the segment count, click on the name of it, Griffith, Stavers, Tenenbaum, click on that. And what that shows you is the concepts that code strongly with that article. So I can see, yes, it is indeed about topic modeling, and I can see that immediately because topic and model, semantic representation, are the most likely concepts to appear in this article. And so if I want to see where Griffith, Stavers, and Tenenbaum talk about representations, I can click on that 68, and it shows me all those text segments which are from that article and talk about that concept. So I can explore the code space using these ranked lists. So that's a quick breakdown of that article. But now let's say I say, all right, so Griffith, Stivers, and Tannenbaum talk about topic modeling. Who else talks about topics and models? So if I click on, let's say topic here, click on topic, the name, I can see that topic co-occurs in the data, codes together with topics, models, conversation. But if I scroll down, I can also see the papers which talk most about topic as an idea. So here's one of mine, here's Griffith's, here's another one. So I can either get a breakdown of an article by topic, by concept, or I can go to a concept and see what are the important articles that talk about that and drill into that. Where does Lakoff talk about topics? Well, in these 4 text segments. And then I could put them in my logbook, which is a little journal of the text segments that you would like to come back to. And they live over here in the log. And so I can show them all. Here are the ones that I've tagged so far, and I can go and put annotations against those. Now I did.
Andrew, can we ask a question about the stop word list?
Sure. Just the final thing I wanted to say, I was really coming to an end there. If you are curious about, I've said that these are concepts, not keywords. You can view the thesaurus here and see how they're defined. So let's go and find just topic just quickly. So this is its latent, the latent concept that's been built around the seed word topic. And there's a list of terms with weights. And if you're wondering why fried chicken's there, well, you can always drill down and see why that has been used in the concept of topic. There's fried chicken there. So that's the thesaurus. Okay, so that's Leximancer in a nutshell. So there was a question about stop words. What's the actual question?
So we just have it appearing in the chat. Hi everyone, my name's Amy. I work with Melody and Andrew. So using journal names that bounce in obviously as the themes, they've been added to the stop word list, but somehow that's not.
Yeah, no, that's not, I wouldn't suggest, well, you could use a stop list for that, but I would
better way.
I would more, well, it would, but you'll never be done, right? You'll always have more journal names you want to put in there. So I can show you how to do that, but a better way to do it is what I showed you with removing, filtering out filtering out bibliographic content based on those tags. So if the citation, the bibliographic style has certain indicators, like they use volume, number, et al, P or PP for the page numbering, it's better to use those a kill tag like I did here to remove them entirely from consideration, so that the model is not built from that. So those journal names which are in those bibliographic entries, they wouldn't show up because the whole bibliographic entry is being ignored. Now, if you have just a handful of things that you want removing from the concept map, again, the way to do that is to go into concept coding settings. And you see here, I left off figure and table because they're used frequently in articles, but I didn't want them. So I just took them out of the mapping concepts list. So it won't code for those, and fig, figure, and table. So if you have, journal names which appear, they're probably going to come in as these name-like concepts. So just take them out of your mapping concepts list is the best way to do it. So if you don't know how to use the mapping concepts list, the way you find Leximancer by default is it will look like this. It will have all discovered names, and all concepts as these two wildcards. What they do is they grab all the proper noun, the named entities which are built around proper nouns will be in the model. And all the concepts from the common nouns will be in the model. Now, if I don't want any of these, just take out all discovered names, and then they won't be there. So if you have journal names, just leave the discovered names alone. Just get them out of the mapping concepts list, and then you won't see them. But you could, you can select if there are particular proper nouns you want in your model. You can just put those in. So it's really the way we design the tool for removing things that you don't want in a particular map is to take them out of the mapping concepts list. Now, I agree that if you regularly are doing it again and again and again, and you keep finding the same things that you would like removing, you could then go to the trouble of putting them in the stop list. So the stop list lives under text processing settings. There's a button here called Edit Stop List. When you open it, don't be put off because it's empty. All that means is you just have to load in the language you're using, which in this case is English. So now I've got the stop list for English. These are words that are removed from the data before it's analyzed. And it's a fairly big list of words in English which have a low meaning, not very semantic, in other words. So you could add another word here. If I added vol there, for example, then that would be removed from the data. And so you can add them there, but do be aware that this is per project. So if I save this, this is just for this project. If I want to create a stop list to use in different projects, I go and add them. So I add all the stop words I want. Then I would hit OK to save it. And this is important. You have to save it by hitting OK. Then come back in, and now you can download it. So once you've saved it and come back in, so the changes are saved, you can then go download, and it will save that stop list to your hard disk. So put it in a folder, and you can then upload it into a different project. So then in my next project, if I want the same edited stop list, I then go upload, and it'll go and I can go and find my own customized stop list and upload it into a different project. Okay, but I would, if you repeatedly have to remove the same things because it's a characteristic of all the types of data you're looking at, then yes, you can put them in a customized stop list. All right. Anything else? Any other questions?
So just a comment, I'm sure Andrew's gone like really in depth with the literature review today, but these principles can be used for obviously transcripts, survey data, all different situations you might find yourself in with data. So Leximancer is obviously very universal, doesn't discriminate what type the data set is in, but there's, particular things that you do for a literature review, which we've gone through today.
Yeah, I mean, you can do all other things. We could do interview analysis. We could do, we could look at framing. So framing is an interesting topic in itself. Leximancer is very good for looking at the way expert communicators frame a topic or a person to do them harm or give them a hand based on how they frame a particular idea or person. Like, for example, we've seen newspaper articles where an incident is framed either as inexcusable, lapse in judgment, or a heinous betrayal of the people, or your fans, or whoever it is, if you're a celebrity. And Leximancer is very good at looking at those sorts of red flag concepts, how they use together to create a frame. And then that's really, when we're looking at sentiment and affect is a technical word for sentiment. or emotional response, you should really look at it using a frame analysis. All right, well, I'm looking at the time. So if there's a specific topic that anyone wants to stick around and we can explore an advanced topic perhaps, but otherwise that's all the general content I have in mind for now.
So we do have we do try and do a very specific topic for each different webinar. Sometimes we'll touch on health data. We've been working with Queensland Health a bit recently on some of their large surveys. We have done the profiling that Andrew just touched on as well. And Melody puts together videos, YouTube videos on specific topics that have Andrew going through in depth on different areas of Leximancer. So we just encourage you to use those resources, or if there are specific questions that you think come up after you've had a play, please reach out to us.
I see someone has asked whether the webinars are the same each month. It's kind of no, but
No.
we get questions. People who register register what they're interested in.
Yeah.
They usually
the questions that you register within, we help to determine the topic, and we sometimes repeat topics, but they are different. The webinars are different every time. We just sometimes have the front end of the webinar being an introduction of obviously the theory, because we just try and get everyone up to speed quickly as we can on the same sort of theory around qualitative analysis if people are coming in with little to no knowledge. But usually at the beginning of the webinar, we'll take a vote as to whether we'll go through that content again. So we can do more advanced webinars, and we absolutely take suggestions from anyone. So if anyone has a certain area of Leximancer they want to know more about, we can just customize the webinar to that.
All right. Well, there are no other questions or comments.
So everyone, as you'd know, will receive a recording of the webinar when we've wrapped up. So thank you to Melody for handling everything behind the scenes. And thank you to Andrew. And thanks everyone for your time. I know it's precious. We really appreciate that you guys take the time.